All right. So this is chapter 16 on waste disposal, and we're going to be starting off with solid waste. And so these graphs show the different types of solid waste that we come across mostly in this country. So we have industrial waste. So this is what's produced from industries, and then municipal is like your household waste. And so you can see in municipal, we have a lot of paper, food, yard waste, and in industrial, we're looking at food processing, paper again, and chemicals. We also have some building materials here, some wood and lumber and stone and glass. In the household usage, other ones would be plastic, rubber, and metal. So the industries, we have agriculture, the mineral industry, which includes spoils, tailings, slag, and other rock and mineral waste. So this is all from mining. So tailings, slag, spoils, all of this is byproducts. I don't know if byproducts is but the waste from mining. And then really the municipalities, the household stuff is actually very small compared to the amount of industrial waste. And then the industrial waste, as you would expect, is a lot more toxic than your household waste. So how do we get rid of our waste? Well, we don't really get rid of it. There are a few ways we handle it. The most common and old-fashioned one would be landfills. I mean, archaeologists are digging into landfills from hundreds of years ago. So this is not really new, although we do understand some of the science behind groundwater contamination and some potential disadvantages to just burying our waste. So let's look at this. I'm just going to kind of review this. Barriers, leach it. All right, so leach it is just the water containing dissolved chemicals. And so that's how we get the groundwater contamination. And so you can see here, if you dig this out, and if your groundwater is this high and you dig a trench here to be your landfill, obviously all of that stuff from the landfill is going to contaminate the water. The leach it is a stuff it will go through the pores in the bedrock and contaminate the groundwater. So it's not like your soda can can't fit through the pores in the bedrock. It will stay here, but all that, it gets wet, the water's going to drain down in here, and whatever the water's been able to dissolve or pick up with it, it's going to get into the drinking water or the groundwater. Here's another example where this time they were smart enough to not put it into the groundwater, but they didn't cover it. And so when it rains, it fills up, it's going to overflow. And then here in this example, it's coming down to where there's a stream, and streams are connected to the groundwater. So now we're polluting not just the groundwater, but also the stream water right there. You can see here it's got this saying this is permeable, and it has this impermeable soil layer, something like clay. Sometimes it's a liner, plastic liner or something we'll put down, but there's an impermeable layer. So it's not able to come down into the groundwater here, but it can overflow. And then here is the same situation without that permeable layer, where it doesn't matter really if it's above the groundwater or not, because it's getting there. Everything is permeable. I realize I should define permeable. Permeable means it has enough what we call porosity in the rocks. Porosity are little itty bitty tiny holes. Sometimes you can see them, sometimes, most of the time, you can't see them with your eye. But there are all these little holes in our sedimentary rocks that we call porosity. And when there's enough porosity that the little pores connect, that's how you get water can flow through the rocks. And we call that permeable, meaning that the water can permeate or trickle through the rocks. Impermeable means even if there's porosity in little holes, the holes don't connect, so nothing's flowing, or maybe there just aren't any holes in the first place. So impermeable means that the water can't trickle through the rock. Here's just another diagram showing the different types of municipal waste. and how to deal with it. So this is how much we have is in our landfill. So it's most of it. Second, we have recycling. And then we're going to talk a little bit about composting and combustion coming up. So here is incineration. Now, incineration isn't just burning. It is burning the waste, but it's burning it at such high temperatures that it actually does destroy some of the toxins that if you just set it like on fire in your backyard, a lot of those toxins wouldn't be destroyed. Now, while incineration is better than just burning it because it does destroy some of those toxins, it's not 100%. It does still have side effects and some toxins that do survive the incineration process. It's going to produce carbon dioxide regardless of toxins. Expensive to operate. I'm reading through, make sure I'm hitting all the talking points. And then, yes, it does produce heat. And if you're smart, you're going to recover and use that heat for electricity or some other purpose. So there is kind of that benefit in using the trash as more or less like a fuel source. Ocean dumping. So I think everybody knows this is a really bad idea, although it's obviously still happening in other countries and has happened historically. That's probably very, very common, especially for coastal areas. And, I'm sure you've heard or seen the videos of like those plastic islands or coastal areas that are now seeing like plastic rocks where the plastic is like melted and kind of almost working its way into the rock cycle, which I'm kind of maybe glad about that because then it's like, well, maybe it's nature kind of helping take care of the problem, but I don't think we can really depend on that. We do still allow waste from like rivers and things. When we want to like clear out a river, if it's full of sediment, we'll take that sediment and we'll still dump that in the ocean. And then this here is talking about incinerating out in the ocean. I guess you're getting, that toxic fume kind of further away from people, but obviously it's still going to pollute the ocean. Oh, here's what I was talking about. These dredge spoils. So sediments dragged from reservoirs and waterways to enlarge capacity or improve navigation, or let's say there's a flood and all this sediments now in the waterway, they'll dredge that out and they'll still put that in the ocean, which I guess I'm okay, kind of okay with because it's not really pollution, it's just dirt. But it does come with, okay, now you're putting more dirt into the ocean than was naturally getting there. So, there's a lot like coral and those kind of creatures. You're going to muddy up their water at a more faster rate than would have normally happened. And sometimes that can really hurt some of the ocean life. But at the same time, like a natural storm or a hurricane or something's going to do that too. So it's like you really just can't win. And then obviously just putting trash is a very, very bad thing. All right. Reducing waste volume. So how would we reduce the amount of waste that we need to either incinerate or put into a landfill? Less volume means less landfill space. It's kind of a no-brainer. So if it's non-toxic organic matter, we can compost it. We can turn it into, composting is turning your food waste and your green waste into soil. And so not only is that reducing the amount of trash and waste you have, you're also actually improving the quality of the soil, and that can be used just for your grass in your backyard, or if you do it at home, if you garden at home, you can put that in there. It can be used on a larger scale for commercial agriculture as well. And then I think we all know about recycling. And so it's not ideally, you should try to reuse and reduce before you recycle. But if you can't reduce or reuse, then you should recycle whatever you can, which would be, your wood, paper, plastic, some metals like aluminum. Um, a lot of energy goes into recycling. So recycling plants still produce a lot of carbon dioxide. It's kind of very ironic. So again, it's not a fix-all solution. Reducing waste volume. So here are some ideas. Recycle crushed pavement as used roadbed material, recycle steel into other useful objects, and used bricks, maybe make footpaths or trails out of them. I mean, there's all sorts of ways you can think, like, what can I use this for before I put it in either the trash or the recycling bin? Here's kind of what I mentioned earlier, that recycling should be like the last reduce, reuse. So first you want to reduce and reuse. So the larger it is on this triangle, it's the most preferred method of handling waste. Then you should recycle after you've reduced or reused. Recycle and compost. Then there's energy recovery, which is, like I said, with the incineration, at least you are able to use that energy and use that incineration as a fuel source. And then least preferred is to try to figure out what to do with it and put it in a landfill somewhere. Here are the graphs that I thought I was showing you earlier. But here are the graphs about the different types of recycled and waste materials. So here we have, let's see, this one is the amounts and percentages of waste and recycled. So waste is red, blue is recycled. And so if you look at the amount of waste, obviously it's gone up significantly. This is what, millions of tons per year. So amount of waste, amount of waste recycled. So if you look at this, it looks like we have stopped recycling, like there's this decrease in the amount of recycled material. But the percent has stayed the same. So actually, the percent of like all recycled or percent of waste that we are recycling. Sorry, I'm just messing up trying to say this. Anyway, so the percent has stayed the same, but the amount has gone down. So it's not that this is showing that people have stopped recycling. It's showing actually that people aren't producing as much waste. And so they're doing a much better job at reducing or reusing, or maybe just not even purchasing stuff that they don't need. Like I know I've recently seen an article that Gen Z doesn't believe in buying single-use water bottles anymore because they know it's bad for the environment. So now they're using just the refillable kind that you carry around. And so if those kind of trends continue, I mean, that's obviously very good for the environment. This graph here is showing the percent recycled in 2018 by type. So you can see like auto batteries were almost always recycled. And that's because I think most people, if you take it to like a shop, the shop is going to recycle that for you. And then followed by tires also, where the industry is doing it for you, kind of saves you a trip there. Then we have steel cans, because I think you can get a lot of money for scrapping steel. Yard trimmings and paper, very high, again, as cities have increased their like green waste pickup. The cities are probably doing a lot of this, more so than necessarily individual people. Other than the people, collecting it and putting it in their green waste bin. And then aluminum, and again, because, well, I think you can get more for it, especially in states that have a CRV, which is not Kentucky, but in some states you get your tax money back if you recycle those. And then, well, it's the tax money you spent for recycling. It's not your normal sales tax. I should explain that. And then net discards of materials. So again, this is just kind of showing like by time, the amount of recycling that has happened. So it should be showing, and it is showing, an increase in recycling in more recent years, except for glass, and yard waste have gone down, which is actually very interesting. I wonder if this isn't maybe because plastic has replaced a lot of glass use. And I don't know why yard waste would have gone down. That's very interesting. And that is it for our solid waste.